Welcome back. In this video, we are going to look at how we can express 120 and 4851 as in the standard form, and then find their least common multiple and their greatest common divisors. Okay, so before you can do this, before you can find their least common multiple and the greatest common divisors, what you have to do is to first look forward for their prime factorization or their prime factors. So once you have the prime factors, you can go ahead and look for their least common multiple and their greatest common multiples. Okay, so let's dive into it. So we look for the prime factors or the prime factorization of 120 and 4851 respectively. So here let's consider 120 first, right? So when we consider 120, we're going to look for their prime factorization. So prime factorizations of 120, prime factorization of 120, right? So how do we know the prime factorization of 120? You know that we are going to look for the prime numbers, right? The possible prime numbers that can divide 120. So let's start with the least prime number, okay, and that is 2. Okay, so we're going to have 120 divided by 2, and that is equal to 60. Okay, the next, so we pick this again, so we're going to have 60 divided by 2, and that is equal to 30, right? So we can see that 30 is an even number, so we can still use the 2 to divide it. So we're going to have 30 divided by 2 is equal to 15, right? But 15 is not an even number. Okay, so we try to look forward for the other prime number that can divide 15, and that is going to be 3. Okay, so we take 15 divided by 3, and that is equal to 5, right? So that is, we have gotten a prime number, so we end here. Okay, so the prime factorization for 120 is going to be 1, 2, 3, 2 power 3. So we had 2 dividing 120 3 times, right? So you're going to have 2 power 3. Then we had 3 dividing 15 once. So you're going to have 3 power 1 times, we had 5, right? So 5 exponent 1. Okay, so you realize that when you multiply 2 power 3, which is 8 times 3, which is 8, 3, which is 24. 24 times 5, which is going to give you 120. So the prime factors for 120 is basically 2 power 3, 3 power 1, and 5 power 1 respectively. So that's the prime factors of 120 is or are 2 power 3 times 3 power 1 times 5 power 1. So this becomes the prime factors for 120. So let's do that 4851. When you sum the digits for 4851, we're going to have 18. 18 is an even number, but when you check the last 2 digits for 4851, it's an odd number. So we consider the odd prime number next to 2. So that is 3. So 3 divides 4851 is going to have 16, 17, right? So this result we have here, when you add it, you're going to have 15. And 15 is an odd number. So, and this 2 is an odd number. So we pick 3 again to divide 1617, right? So this divides that 1617, and that is going to be 539. Okay, so this result we have right here. Okay, this result we have right here. This, when you add this, you're going to have 5 plus 3 plus 9. Okay, and this is going to be 8 plus 9, right? And that is 17. Okay, and 17 is an odd number, right? But you cannot use 3, which is an odd prime number, to divide 17. You cannot use 5. You cannot use 11 or whatever. The best option for you to divide 539 is to divide it by 7. Okay, so we take 539 divided by 7, and that is equal to 77, right? 77. But we know that 77 can be can 77 can 7 can go into 77, right? So we take 77 divided by 7, and that is equal to 11, right? We know that 11 is a prime number, so we end it here. Okay, so now the prime factors for 4851 is going to be 3. We have 1 3 here, another 3 here, so it's going to be 3 power 2 times 7 here, 7 here, so it's going to be 7 power 2 times 11. Okay, so you have 11 power 1, right? So when you multiply this result, it should give you 4851. So we have 3 squared times 7 squared times 11, right? That is 4851. So the prime factors, that is the prime factors of 4851 are 3 squared times 7 squared times 11 power 1. So this element becomes the prime factors for 4851. Okay, so let's look at how we can express 4851. Let's look at how we can find their least common multiple and their greatest common divisors. So we come here. So with the greatest common divisors, what we consider is that, you see, we have 2 power 3 here for 120. The prime factors for 120 is 2 power 3, 3 power 1, 5 power 1. And the prime factors for 4851 is 3 squared, 7 squared, 11 squared. So we check through these two numbers, okay, these two numbers. The one with the least exponent, the smallest number with the least exponent. Okay, so this integer 2 power 3 has an exponent of 3, but 3 here as the next integer has an exponent of 1 here, and it has an exponent of 2 over here. So we consider 3 exponent 1 because it has the least exponent. It has the least degree. So the greatest common divisor becomes 3 power 1, and that is equal to 3. So the GCD of 120 and 4851 is 3 power 1, and that is equal to 3. Okay, so we have the idea of how we can obtain the greatest common multiple, the greatest common divisors among two numbers, right? So now let's put this here. The 120, it has 2 power 3, 3 power 1, and 5 power 1, right? So let me clean this here. Okay, so with the least common multiple, what you have to consider is that you look through, you see the 120 has these prime factors and the 4851 has these prime factors. So you check the prime factors for 120 is 2 power 3 times 3 power 1 times 5 power 1. And this is 3 squared times 7 squared times 11 squared. So consider these two, compare them, okay? Compare these two and take those, each element, right? Each element with the highest power. Each element with the highest power. So we're going to have 2 cube is here. We don't have 2, any term called 2 here, right? So we consider the integer with the highest power, right? So the integer with the highest power, 2 with the highest power is 2 power 3. And we don't have 2, any of 2 here. So we pick 2 power 3. And 3, when we consider 3 has the highest power in 4851, which is 3 squared. So we consider 3 squared. Then we omit 3 power 1 because it has the least power, right? Then we come to 5. 5 has an exponent of 1 here, but we don't have 5 here. So we consider 5 exponent 1, right? And then we have to come to 7. 7 has an exponent of 2 here, but we don't have 7 here. So we consider 7 exponent 2 times 7 exponent 2. Then finally, we look for the 11. 11 has an exponent of 1 in 4851, but we don't have 11 here. So we consider 11 exponent 1, right? So when you multiply this element, you're going to have 194040. And that becomes the least common multiple for 120 and 4851. Ladies and gentlemen, this is the process we go through to find the least common multiple and the greatest common divisors. Thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mates, and I'll give you more updates. Bye-bye.